All right, welcome everyone to our webinar today. My name is Austin John. I'm the marketing specialist here at Structures.Aero Design and Analysis. Today's webinar is presented by Ryan Tapman, who is an aerospace thrust engineer here, and our topic today is an analyst guide to resolving common geometry problems. So really our intention with this was, as an analyst, you might be getting once you get your model from the designer, how can you deal with it and tweak it so that it's ready for analysis within your finite element environment. And today to be doing that will be in Femap, and so I'll let Ryan go ahead and get started.
Okay, so as Ashwin said, we're basically just going to try to use Femap to do some simple geometry things, common geometry problems that you might get from a designer. So we're going to walk through two main models. One is a flawed wing box, and some of the problems in this one is you've got a very thin solid. So when they do the CAD, they've got a thin wing skin, and they have that modeled as a solid, not a surface, which for structures we'd like a surface, but I'm going to go through some options we can do that isn't just sending it back to the designer and saying, hey, can I have a surface? Because sometimes there's a bit of a disconnect or a lead time associated with that. And then we're also going to talk about alignment. I know with a lot of big projects, you sometimes get multiple coordinate systems going on, and a designer might send you a part that's part of a complex system, but it's in its own coordinate system. So when you bring it into your large analysis model, your FEM, it'll be in the wrong place. It'll be oriented in any number of degrees off of where it needs to be. So there's some tools that can help you do that, and we're going to be using Femap and using Femap specific tools for those. So I just want to first say, as a start off, that the first thing you should do before messing with any geometry is to kind of figure out what the design intent is. So these are things like, is the OML, the outer mold line, the midplane, or the IML fixed by design? So if you have a wing skin that's a composite material, usually your OML is fixed, which just means that the tooling is fixed and you're building, any thickness change you make is going to go into the wing body, but the OML of the wing is going to stay constant, and that's for aero and for manufacturing reasons. You want to find any features that might be ignored. There's no point in bringing very small bolt holes through your analysis model when you're going to ignore the stress concentrations due to them in the future. So taking those out as early as possible can save you a lot of time. And then another fairly common thing you should take into account is, are there obvious additional features that need to be added? So I put an example in here where you have a control surface on the wing, but there's no access panel modeled, right? So you know that there's probably going to have to be an access panel in there for them to access a servo. So you might make a little box in your FEM that can easily just be taken out and remeshed, so you don't have to remesh your entire wing skin just because you need to add a small feature. Little things like that can save a lot of time in the long run. All right, so we're going to dive in. Let me bring up. So this is the FEM we'll be working with. I copied it over a few times just in case we have any mistakes. So my first step usually when I'm dealing with a thin solid is to explode it into its individual surfaces. That makes things a little easier to deal with in the long run because you don't have weird interactions between your surfaces. So Femap has a built-in tool through the geometry solid explode. And we'll just box select here. So now we've taken our solids and broke them into individual surfaces. And we can use the draw race tool, which is relatively new to Femap, but can come in handy in things like this. So we're going to make sure it's set on a race. We'll grab and select our surfaces that we want to deal with. And I set it to a race and choose the things I want to deal with just because once I select them, they disappear. So I can make sure I've grabbed the ones I want and it doesn't get in the way. So we'll just change to pick front, and I'll grab the important surfaces, which would be the tooling surfaces of these. This is how I'm treating the first set that we're going to do is a general OML mesh. I think I've got them all there. Now I'm going to flip over to the draw, and that's going to show me the things I picked. So I'm just going to glance through here and make sure that all makes sense. And it looks like I got what I wanted. So the tool also comes with a pretty convenient feature that you can go through the drop down and select Create Group, and it'll let you name the group. So we'll just name it Working Group, something generic. So I'm just going to add the related entities and turn automatic add now just to decrease confusion later. So now we have a working group that we can start working with. First thing I think that makes sense for this model specifically is to just get rid of any unneeded features. So these bolt holes that look like maybe a servo mounts here, probably don't need those. This is pushing maybe. Maybe you might want to model this, but I'm not going to model this in this case. It's fairly small to the shear web. I don't think it's going to be an issue. So through the meshing, see, I'll make this bigger so you can see a little more. The meshing toolbox, we can go to feature removal, and loops is what they mean by circles. We have options here where we can add surface mesh points. That's going to make sure you have a node exactly where the center of the hole was. I'm not going to make any interfaces, so we won't be doing that. And we'll just click here, and we can get rid of these with a single click. All right. We're going to keep this large pass-through hole because it most likely has impact on the stress long run. So next, I think I'm going to extend these spars up to the skin. You can see because we only grabbed OML, we're going to have these little gaps. Femap also has a built-in tool for this through the geometry editing tab on the meshing toolbox. It's called Extend, and there's a couple options we have here. We can extend to a solid. We can extend a certain distance. We're going to do a solid, and we'll just grab our skin we have here. Okay, for some reason it's not letting me do that. Okay, sorry about this. For some reason it's not recognizing this as a solid. Oh, sorry about that. I need to reset my draw erase. I think that might be a bug, but that is an issue. Now it'll let me select it. I can go through here, and just by selecting the edge here, it'll bring it up to contact the solid. And in this case, this tool actually slices the solid. It projects the curve onto the surface. So you can see if we go to list surfaces, now we've broken up that single surface into multiple surfaces. But if that doesn't work, or if you use a different method to extend these out, you can always go through geometry, curve from surface, project, or intersect. Slice will also let you choose a plane. So in this case, we could choose the plane of the spar web, and that would slice our skin where we want to. But our skin is already sliced, so we can skip to the next. All right. So for other geometry such as this, you can do the same method. So we can go to our feature removal, we can choose the curves, and we can get rid of these features. And we could even go to the extend command, change our solid to the spar, and then extend this out. But you'll see it's a little messy because we have curves. It doesn't extend it very cleanly. So sometimes with complex things like this, it can just be easier to use boundary surfaces. So under geometry boundary surfaces, you can choose from curves, and that's going to let you pick curves that surround a surface you want to make. And there's no limit to the amount of curves The only limit is that they must make a closed boundary. So in this case, you can see our our extend tool actually messed up this curve. It actually made it into 3 curves. So we got to make sure we collect all 3 of these, and we'll check to make sure we have a closed boundary. Click OK, and that's going to make a boundary surface, which is not the same as a surface. So we can go to Surface, and the Convert tool will convert that into a surface. And OK to delete original surface, that's talking about the boundary surface. I have no use for the boundary surface after this, so I'm going to choose yes, and that's just going to give us a surface that closes this out. So we'll need to transfer the important features from our original surface to this new surface, and we can do that with geometry, curve from surface, project. So it's going to tell us first to pick the solid we want to project onto, the surface we want to project onto. And we'll choose our curves. That's going to project it on there. And at this point, we don't need this yellow surface anymore, so I'll just delete the solid, which will take the surfaces that are associated with it out. And I'll delete this surface, and now pretty quickly we have a clean meshing surface. And here we'll just repeat the process. So geometry, boundary surface from curve, then geometry, surface, convert, and we'll project our important geometry. We'll go ahead and delete the unneeded solid, and we'll delete the part of the surface that we don't need. All right. So boundary surfaces can also be helpful for things that just weren't included, right? So maybe there's supposed to be a rib up in this leading edge, but for one reason or another, it didn't come through. We would still need to ask if there's any important features on here, but boundary surface can be used to just quickly and easily create new surfaces. So we're just going to create leading edge ones here. Remember over here we have this weird curve that got messed up by our extend. So we'll have to choose all 3. And we'll convert them. And we have a clean leading edge rib. So the trailing edge, we might want to do a similar thing. But you'll notice it won't let us do it. So it's going to give us an error that said selected curves do not form a single closed loop. And you could spend a long time looking around. I happen to know it's because this was initially modeled with a blunt trailing edge. It's a fairly common thing to do. So if I go to the full model, you can see the solid has a blunt trailing edge. So we don't have a closed boundary, so we can't create our surface. We have a few options here. We could just connect the 2 edges with a very thin surface that goes across here. I don't really like that idea because it's going to force a really high fidelity mesh, because in order to get these at a reasonable aspect ratio, the elements on the entire wing skin are going to have to be fairly small. Another option would be to use the geometry editing extend tool, and we can change this over to a distance, and we'll just choose an inch, and that'll extend it out, and we could trim it at the intersection point. But that makes the skin a little long, and in this case, you know, might not be ideal. Maybe you think it's going to add some stiffness to your wing because you're adding a little bit extra material. So in this case, I'm actually going to Control-Z out of there, and we'll just move these curves to be coincident at the midplane. It's going to move this entire surface, but by such a small amount, I think this is the best option in this case. So a good way to do this would be just to create a point in the midplane. So we can just geometry point, and it's already there. So we can, under the methods, we can choose between, and it'll give us percentage. And we want the midplane, so we'll choose 50%, and we can grab the upper point and the lower point. That's going to give us a point in the center. Now through the modify move by curve command, we'll grab this upper curve and we'll create our vector from this corner to the midpoint we created. That's going to move it down. Very similar option on the bottom, operation on the bottom, moving it up, and now we have a clean trailing edge single point. So next we might want to add these flanges. So a lot of times you want to model a double thickness here because your spar is going to have a flange that's going to be used to fasten to the skin. So what we can do here is just bring back our full model, and we'll use the draw erase to get some of these surfaces out of our way so it's a little easier to see. So these are what I'm talking about, this surface, and we'll just start with the spar cap. We're going to want to add these surfaces to our working group. So we can do that just by, usually a little easier just to list them and then add them separately. That way we're not locking ourselves into anything. So list surfaces, I'll use a pick query here. We'll just go through, that's the surface I want. I'll grab the reverse. So now we have these 4 surfaces. I'll just copy, and then using the group surface ID, I'll paste those in, and it's usually good just to add related entities. That's going to bring the curves, the points, everything in there so it's easy to work with. And we'll just go back to our active group and close this tool so to make sure not to miss something. And actually, I probably don't want that there. So now we have to transfer this line up onto this surface. Easy way to do that, like I mentioned earlier, is the curves from surface project. So this is going to project normal to the surface you're projecting onto, which in this case is probably what we want. So we're just going to do that. There's other options in there that you can define vectors, but in this case, this is what we want. So we choose what to project onto, and then we can pick our 2 curves. Those are going to shoot right up there, and you can see it's already split our solid, or it's split our surface into these small surfaces that we can mesh separately. We can make sure that there's a different fidelity mesh on there. This just gives us more control over the area. And we'll repeat the same thing down here. So another option for these, and I'm going to show in here, and we're just going to hide this again. This would be a lot of projecting, right? So these rib flanges, they interface a lot. So I happen to know that this is a constant flange width, which is a fairly common feature. So what I can do here is just under the tools, measure distance. I'll make sure to get out of here just to locate. I can just measure the width of this flange, 0.46 it looks like. And we'll go back to our working group, and through the geometry curve from surface slice, we'll just grab our skin, and we can also grab our spar caps. It might not be a bad idea to have it on there as well. Or I guess we have to do one at a time. So we'll define our plane right here, and we can offset in the Z, because I know that the Z is my span direction. I can offset plus 0.46, and I'm just going to copy and paste that down to all of the Z's. And this is just moving my entire plane over in the Z direction by 0.46 inches. And you'll see it gives us a nice line, splits everything up nicely. And I would repeat the same step for the spars. To save time, I'll just ignore that for now. But we probably want to do the other side for completeness. So we're going to paste this. We need to go in the opposite direction this time. That's going to give us that. All right. So now we want to get rid of our working surfaces. So this really has no place in our working group. So through the group surface ID, we can just remove these from our group. Okay, and we also could have removed the curves and the points by doing the same thing, just curve by surface or select them individually. But since the groups are largely driven by solids and surfaces, what I can do here is just go to curves, and sorry, this is a hot link to group curve ID. I can just reset it, and I'll do the same for points. And then through the add related entities, that's going to add everything back that I wanted, but it takes away the points and curves related to those surfaces I removed. So here I have this, and I'll just close out these back panels using our boundary surface. And now we have a pretty clean looking, easy to mesh geometry. So now if we mesh this, the mesh for this rib won't talk to the skin because they're separate solids. Femap has a built-in tool for this, and it's non-manifold add. It's a fairly common tool, and it's very helpful. So through the non-manifold add, we could just select all of these surfaces because that's everything we want to non-manifold add. We'll click OK. It'll give us a tolerance. The default is fine unless it doesn't work, and you can decrease this, but the tool becomes less and less stable as this number decreases. So just keep that in mind. We'll notice here that it didn't work. So these highlighted lines are free edges, and you can see here that there's obviously not supposed to be a free edge between our rib and our skin. So something didn't work right. So the first step would be just what I explained earlier, which would be to non-manifold add, repeat the same step, and maybe drop this to something like E-4. Also doesn't work. So in this case, obviously these are all perfect surfaces connected, so the tolerance wouldn't fix something like that, but it's always a good thing to try. What's happening here is actually that we have a bisecting surface contacting a solid that's already been non-manifold added. So without going into much detail about how the non-manifold add tool works, a good solution, and this works a lot of times for situations like this, is to just go through your solid and explode it. So this is a single solid with all of these different surfaces on it, and something in there is not liking this non-manifold add tool. So by exploding this into individual surfaces, we're giving the non-manifold add tool a little more freedom to decide what's connected to what. So if we repeat the same thing, we'll just select all of these separated surfaces and click OK. We'll notice that it did work this time. So we have two free edges, but those are the pass-throughs, which is what we'd expect. So this is a non-manifold added, fairly easy to mesh, clean geometry that took 20 minutes. So fairly fast, probably faster than handing it back to designer to get this thing, and you know it's tailored to you. The last thing is usually composite curves and combined curves and combined surfaces. These are really unstable for geometry manipulation. You won't be able to apply a lot of the built-in Femap tools to a composite curve or a combined surface. So you should really do this right before you mesh. So in this case, I'm just going to show how they work. There probably is a better method for this, combining this 3 lines into 1 line, but sometimes the tools don't work and you're forced to use a combined curve. And this is how it works. You would just add by point is a good way to do it, or you can add by curve, and you'll just grab your points. And what that's doing is telling the mesher that, you know, even though there's a point here, treat this entire curve as one defined mesh. So you can set your mesh attributes along this entire curve. It'll split it evenly. It'll work more cleanly. Same is true for surfaces. There's really no good examples in this particular geometry to show it, but it works very much the same way. We'll add by surface here, and we'll just click the dialog select, and if we grabbed both of these, you can see now they're combined into one, and that just means that there won't necessarily be a line of nodes here. But that's pretty much it for the OML approach. We'll switch over to an IML approach really quick, just to show how there's small differences, but the gist of it is very similar. So what we're going to do is just create a new group, and we'll just call it IML approach. And we're just going to group our solid in this case, which is just the skin. There's no need to redo everything here because after we do the skin, most of it's going to be very similar. So we'll change over to our active group. We can see our skin, and I'm just going to move add related entities and automatic add over to this group, and we'll start working on this. So the automatic mid-surface tool is a great first step for anything. It's a very robust tool. So that can be through the geometry mid-surface automatic. And all you have to do here is choose your solids. So in most cases, you can just select everything. And you click OK. Your target thickness, I happen to know that this one is 0.015. And all this is the thickness of what you're trying to mid-surface. And the skin thickness for this wing is 15 thousandths. We'll just click OK. So in this case, it doesn't work. And this happens from time to time, and there's other manual options in here that can help. So what we can do is through the same geometry mid-surface, there's an offset tangent surface. And that's going to be more of a manual approach to mid-surfacing. In this case, we probably want to grab our outer surface. We'll click OK. Mid-surface tolerance, not very applicable in this case, but you can mess with this if it's not doing what you're expecting. This is a good way to see if maybe your tolerancing is the issue. Your tangent offset, positive inward, be sure to note that. But my offset distance is going to be half of my skin thickness, so it'd be 0.015 divided by 2. And we'll click OK. Delete original solid. I'm going to say no in this case, just so we can make sure it did exactly what we wanted to do. And we'll zoom in here, and we can see that's a fairly convincing mid-surface. So it looks like it worked. I think I'm happy with it. So I'll go and delete this solid, just so it's easy to work with. And this surface here, I should have pointed out sooner. This is the only surface that came out of the automatic mid-surface. And that's just because you can see in our original model over here that mid-surface found these two parallel or nearly parallel surfaces and made a surface in between them. That's how the mid-surfacer works. In this case, it didn't work, and I'll go into why it didn't work in this case in a little bit. So what we might want to do here is to fix this trailing edge in the same way we did before, and I'm just going to delete this surface because it's not useful to us. So if we went to geometry, or sorry, modify move by curve, and we would create a midpoint in this case, but this won't work, so I'm using this as a demonstration. It's not going to let us move these, and this is because this entire OML surface is a single surface. It's the same reason our automatic mid-surfacer didn't work. So a good way to do this, to fix this problem, would be to go through our curve from surface, and we just need to slice this in a place that makes sense for our mesh. So I'm just going to pick the aft spar, and then it's going to release this curve in these surfaces to be able to be moved. So we can do that through the slice command. I'll grab this, and in order to get the reference, so it looks like I do need to grab that surface before I do this. So right now I'm just grabbing a reference surface so I can know where to slice. I didn't mean to delete. Sorry. Group. Surface ID. And here we can curve from surface, slice. We'll grab our entire OML surface, and we'll define our plane. It looks like I need to add the curves for this in order to do this. sorry. And now we should be able to define our plane at our spar. It's going to slice this. We'll go to our trailing edge, create our mid-surface point, or our mid-plane point, I should say. And now it's going to allow us to move this curve just like we did in the other model. So that's about it for the wing. The rest is very similar. Mid-surfacing approaches, the automatic approach will work for every other surface in this case. You could mid-surface your spars, you can mid-surface your ribs, and that's a fairly self-explanatory tool. So I'm going to switch over to this bracket to talk about aligning real quick. So this is just a case where maybe you have this bracket and they sent you the geometry and someone else's mesh and they're not lined up. So the best way to align something, in my opinion, is through the align tool, which is through, it's going to be modify align. And we're going to assume that in this case the geometry is correct and the mesh is wrong. So we can align our elements. We'll select all because it's the only thing in the model. And there's a couple options: vector to vector, plane to plane, and between coordinate systems. Plane to plane is by far the easiest to use as long as you have a reference plane that's pretty well defined. So we'll do this one first. And what we're going to do here is just define our plane on both. So I'll grab this corner, and that corner, and we'll move to the solid. Same three corners. It's going to take a second while it figures it out. It's a fairly high element count mesh, but you'll see it's all lined up. If you don't have a common mesh, and I'm just Control-Zing now, backing out of that, another common way to do it is to use the bolt pattern. A lot of times between iterations of models, bolt patterns don't change, so they can be a fairly constant way if you don't have a flat surface to move things. In this case, I know it's a pretty clean mesh, so I can jump from this node to this node and find the center. There's a bunch of other ways to find centers. I won't go into that here, but in this case, we're going to use our same method between. And Smart Snap will get us to just grab these two. It's going to give us a point in the center. If I turn points on. Do the same at this bolt location. And we'll choose this as our last bolt. So now we're going to do the same thing down here by making the same points in the same centers of the same holes. And I'll use the method center here just to show some other options we have. Just select a curve. It's going to create a point at the center. And now coordinate systems is how we're going to align it. So through model coordinate system, we can define, and we'll just say from, and we're going from the mesh. So we'll just do XY locate, reference to the global. And we'll snap to point. We'll define this as our origin. This will be our X, and this will be our Y. And we'll turn on to make sure that worked, and there it is. And we'll go to this one, and we're going to say 2. Same, make sure all the options are the same, and we'll select the same points, origin, X, and Y. It's coordinate system here. We'll spot check them. It looks correct, and now we can use the same modify, align, element, select all, coordinate systems, and we can go from to our 2. And this is going to work the same way. This is kind of a long way to get to the same answer, but sometimes you don't have a nice, clean, flat plane to reference. So that can be a helpful trick to know. Next, for small changes in your mesh, a lot of times I'll see that people delete their entire solid mesh just to make small changes like a bolt hole diameter change or a fillet change, maybe your flange width increased. So there are options in Femap that you don't have to actually delete your mesh and recreate, and you have to have an associated mesh. So through modify associativity automatic, we'll just select all and select all. Search tolerance, you can mess around with this if you're getting bad results, but the default is usually fine. And I like to check on group nodes and elements not associated. That keeps a little bit of traceability to make sure it's doing what I want it to do. Click OK. So what this is doing now is it's looking at the mesh and looking at the solid and trying to pull nodes and associate to curves. It's trying to pull element faces to associate to surfaces. And this can be really helpful if you have an unassociated mesh and you have geometry, and then you need to apply something like a distributed load. This will help you kind of, instead of choosing individual nodes or having to rely on element face growth algorithms in Femap, you can just choose the faces, just like you would if you created the mesh in Femap in the first place. So it should be associated. There's no groups made, so it means that every element, every node, and every face found something to associate to. And now a good trick we can show is the feature editing, and this is what I'm talking about, resizing holes and not remeshing. So let's say a small change, like these are a 1/2 inch diameter, and the designer says we need to change them to 3/8. So we could just resize the hole, change the hole diameter to 0.375, and we'll just use this, and we'll just say that only these 2 bolts changed. Click OK. And what that's doing is it is actually deleting and remeshing. So if you have interfaces that are attaching to this, they could be broken by this. RBEs that reference nodes will be broken, but the nodes should be the exact same location except for the areas that you're changing. So going to a tool, check coincident node command will get those connections fixed without much user input. But you can see here the mesh was relatively clean, relatively fast, and now we have slightly smaller holes. This will work the same for surfaces, so we can surface and we'll offset, and we'll say the designer says we need an extra inch of edge distance on these bolt holes for some reason. It's fairly quick to choose this, and that's just going to grow that edge out 1 inch, and then it's going to remesh. So screen updates. So you can see pretty clean mesh update, fairly quick, and really low user input as far as things go. But that's all of the tricks I have for you today. I hope that was helpful. I think we will have surveys and questions available afterwards, but thanks for attending.